Hello, welcome back. We are going to continue our discussion about Chapter 15, Linked List. So in the previous sections, what we discussed is about singly linked links. Singly linked list. So for singly linked list, so the traversing is in one direction. So from front to back. So only support forward connection. Okay, because it's only support forward connection, so it's one direction when you do traversing. In this section, we're going to see the linked list implemented in both directions. So it's linked in both directions. So it will support the traversing both forwarding and backward. So not just front to back, can also like front to back, can also back to front. Okay. So this linked list, we call it a doubly linked list. So for doubly linked list, in order for it to be also able to do backward traversing, then the node unit, so the basic building unit about node, not just to have the next reference to the next node. So we also going to have a third part. So we call it a previous. So this is a reference point to the previous node. Okay. So for a doubly linked list, then the basic building unit, the node, not only have the next node, but also going to have a previous node. So has a pointer point to next node, also have a pointer point to the previous node. And the data part is still the same, okay? So for the UML diagram for the node class, then the data members, it has data, previous, and the next, okay? And the constructor, when we create constructor, we also specify what's next node, what's the previous node. So that's the general concept about doubly linked list. So it supports the traversing, both forwarding and backwarding. Because it doubly linked list support both forwarding and backwarding. So if you recall, previously we also discussed the iterable interface as well as iterator interface. Okay, and for iterator interface, it's forwarding. And the purpose of this iterable is for each loop. And for the iterator, so with the implementation of iterator and also iterable, so we also support like adding and removing within the loop. So the loop will not be terminated due to the adding or removing operations. Okay, so that's a general concept for linked list, singly linked list implement iterable and iterator. And for doubly linked list, due to the forwarding and the backwarding, so the iterator then in Java collection framework, it has an iterator called ListIterator. And this ListIterator, so it supports two-way. It's not a one-way iterator, it's a two-way iterator. So it supports for both forwarding and backwarding. Okay, so similar as what we implemented, what we defined for the singly linked list, we define a linked list iterator that come from the iterator interface. Okay, implements iterator interface. So here, similar, then we call it by linked list iterator, and it's going to implement this two-way iterator. Okay, we call it list iterator, and it is from Java collection framework. And for it, then we need to have a node to remember the current position node, okay, in the iteration. And because it also supports backwarding, is it? So we also need to have a node that remember the last visited, so last access. So that's the a node returned by either next or previous call. Okay, depends on the situation. And we also have the index position for the current node in this case. And for this by-linked list iterator, we have two constructor, one default one. The default one is just create the iterator with current node set to the first node. Okay, or you can specify the index, then it will return. It will create the by linked list iterator with current node set to the specified index position. So it's not start at the first one, start at some position that you specify. Okay. So has next, it's a similar concept. So has previous and previous also similar to next, but it's backwarding. Okay. It's returns from the current node, but back the current position to the previous node. Okay, so has previous is just to check if it has more elements. Okay, when traversing in the reverse direction. Okay. And the next index, previous index, just return the index of the current and the previous node. And you also support the add and remove method. So similar as as the singly linked list. And in our implementation for doubly linked list, we also going to let our linked list implement a interface. We call it a listable interface. And this interface basically is our user defined. So we define a sub interface from the collection interface. So it's going to support all of the method from the collection interface. Okay. So within this interface, we support add method, equal method, get, index of, remove, size, and iterator. So this is the forwarding iterator, and list iterator is a two-way iterator. So this is a one-way iterator, and this is a two-way iterator. And all of those methods, they are abstract methods. Okay. And also, we also define a number of default methods. So default method is already implemented. So it will be implemented within this interface. Okay. We will see that. And then our doubly linked list is going to implement that listable interface that we just defined. Okay, so for this doubly linked list, as previously we saw, it has the head node, tail node, and the number of the nodes in the linked list. Okay, so it's not just has a first node, it also has a tail node because we want it traversing in two ways. In two ways, is it forwarding and backward? And when you do forwarding, you start at first, and when you do backward, you start at back. And back, it's the tail node. Okay, so that's why we need that. So for this doubly linked, we have constructor similar, add, remove, and but there are some difference with the implementation for the singly linked list. For the add method, we can also specify the index and insert after it. Okay, and remove item, or you can remove the item at the specified index. You can also find the index of some specified item. Okay. You can also retrieve the value from the linked list at the specified index. ToString similar, equals method similar as previously. Okay, it's always the case to override the method from object, and clear just reset the list to empty. Okay, and the size just give the number of items. So here we have the list, the iterator. Okay, so it's the one way, and here is a two-way linked, two-way iterator. Okay, and we also provide another two-way iterator at the specified location. So that's the general framework for this linked list class. And from the previous discussion, we can also see to implement this doubly linked list, it's a little bit of complicated, okay, compare with a singly linked list for share. So we have this new tail for its instance variable. Okay, so head tail count. So this part is the instance variable. And we can see the linked list needed to access it. The by linked list iterator also access it. And both the linked list iterator and by linked list iterators, they also need to be able to access the node class. Okay. And for those instance methods, we can see the access the linked list iterator and also by linked list iterator and the node. Okay, and of course, they also be able to access the instance variables. Okay. So that's all the general concept about the doubly linked list. So what next? Let's go ahead to take a look the coding implementation. Okay, so this implementation is in our textbook example, Java linked list example 3. Okay, totally there are 5 files. We have the car class defined and the clonable interface defined, and we have the listable interface and the doubly linked list class, and the testing driver for our doubly linked list. Okay. For the car and the clonable interface definition, it's the same as in the previous examples. Okay. So let's first take a look uh, the listable interface, the definition. Okay, so here is our definition for the listable interface. So it's a sub-interface from the collection interface. It's an interface. And the abstract method, as previously we showed in the UML diagram, is that we have the add method. So this is not implemented because it's abstract method. Same thing for equal, get, index of, remove, and size. And iterator, list iterator, okay. And the difference between these two is this is one-way iterator, so from front to back, and this is two-way. So both forwarding and backwarding, okay. So those of the above are abstract methods. So they are not implemented, okay. And below the method, they are all default methods. So default method has implementation. And the nice thing for some interface to have the implemented method defined as default methods is uh, if you want to upgrade your interface so that it won't impact of the class that implements the interface, then you just add the method as default method. Then in this case, all of the classes that implement this interface, they don't need to also do upgrading. So that's much convenient because otherwise, uh, uh, whichever the class defined using this listable interface, then they also needed to implement that abstract method. So that's not convenient. But with default, then yeah, it's you don't need to worry about that. So the default, okay. And we can also see in the implementation of the default method, it's allowed. So it's allowed to call abstract method. So that will add convenience. Okay, so so the size function it's not implemented, it's abstract method, yeah. But in default method, you can go ahead to call it. And why we can do this is because anyway, in the class that implement this interface, it's going to implement this abstract method. So that's why you can do this. And let's take a look more. Is it add all? Add all. So here you add all is a collection. Okay. So the type is a collection. And a collection is an interface. Okay. And for this collection, and we are also going to the generic is it? It's we try to use the car class in our test, and so we say okay, it's going to extend the T. Okay, and over here similar, you can call the this is empty, it's a default method. Okay, of course you can go ahead to call. And because this is collection, so collection automatically support the for each loop. Yeah, so we can go ahead do it. And then we call the add method. Add method is another default method. And for contains method, what do you do then? You call that index of method to do the check. Okay. So here is a method for add. So add an item. Okay. So it so if initially it's empty, then you just add to the beginning, is it? Otherwise, we always add at the back. Okay. So that's why you specify this, you call the size and add at the back. And here the method is called toArray. So it's to try to convert the items in the linked list to an array. So this is also default method. What you can do is you need to create an array. Okay, so here you can call the object, new object. And then you can call the get method and assign it to the array, and then you return the array. Okay, but of course, be careful. Yeah, here, because if you have this get method, the get I method, then we need to make sure the return is a deep copy or shallow copy. Or shallow copy. Okay. So if we needed to take into consideration of security. So security is considered or not considered. So then it will also impact the implementation of the get I. Okay, because you want to expose each of the linked list nodes or not. And some other default method, we just leave them as exercise. And next, let's take a look of a doubly linked list. So this doubly then to implement that listable interface that we just defined. Okay. So for this linked list, we have the node be defined as inner class. And also it's a static, okay? So you can see we have this new field called the previous to keep track of the previous node. And the remaining is pretty similar as what we already discussed before for singly linked list. And here for the instance variable, we have this new field tail to keep track of the last node. We also want to keep track of total number of nodes within the linked list. So the default constructor is just create an empty linked list. An empty one, so then both the head and the tail are going to be null. Okay. Because it implements a listable interface, if you recall, in the listable interface, we have this add method with index, specify location as an item, is it? So here you do need to implement it. Okay. So the implementation uh, has a lot of similarity between this one and the previous singly linked list. Okay. So here empty linked list cases, and here it's if you add at the back. Okay. So of course, whenever you want to add a new node, you need to create the new node called new. Okay. And you specify where you're going to insert. Okay. And then you do the traversing, is it, to find the last node, and then you set up the new node. But don't forget to set the tail in this case also. And here is to insert in the middle. So you first need to find where to insert. So we do the traversing, is it? So once we find it, okay, you create a new node with the next. Uh, this is a previous, and this is next. Okay, so specify. Okay, with the new nodes previous and it's next, and then you also connect that. Okay, because this is your new node. New node. Okay, and here is the previous. Basically, this is a cursor. You want to insert after it. Is it? This is cursor next. So you need to set the new nodes next to cursors next. Is it? And you also need to set new nodes previous to cursor. That's what we already did. Is it? But not just this, because this is two-way. So then cursors next is this one. But it's previous. You also need to set it to new node. Okay. And also cursors next. You also need to set it to new node. So when we have uh, doubly linked list, you just needed to be careful, okay? There are two node reference for each link that you need to take care, both previous and the next. So for insertion, we needed to be careful about this differences. Similar when you do remove, it's similar, okay? And for the equals, so this is doing the structural equality check, is it? So you need to check the class, if the class is the same here. And then we also going to do the traversing. So here we can use for each loop, okay, because it supports the iteration, okay. And then just check in. So it's pretty similar as what we previously discussed for singly linked list. And then you can have this get method. And previously, like what I mentioned, so it depends on this because this is a reference type. Reference type. Okay. So it depends if you want to return a copy. Okay. So if you want to return a copy, better call the clone method. Okay, because over here our T support the clonable interface. Okay. So to prevent any like uh, the aliasing problem or directly access the node information, is it? Then you can call the clone method so that it's a deeper copy, and you can hide the accessibility of the node's data part. So this just be careful, okay? Whenever we have this kind of a return object. So index of, just try to find where the location is. So it's pretty straightforward. For remove, the same similar. Okay, so consider different cases. Is it if it's empty, and if it's the first node, and because if it's the first node, you need to be careful to reset the first. Okay, here it's not just next. And you also need to take care of the previous node pointer, okay? And or you're going to remove in the middle, is it? And or at the last. So when we do that, we need to be careful to also take care of the previous part for the doubly connection. Okay, so you can draw a diagram to that will help us to reset the previous pointer or the next pointer. Okay, so similar for the remove, for this remove with the specified location. Okay. And at a certain, if like it's not, then we can throw some exception. And the clear method is pretty straightforward. You just reset header and tail to null, okay? And sign, you just return the count. And the toString you can use for each loop and create the string. And then let's take a look at the iterator method. So iterator method, so this is similar as a singly linked list because it return iterator, okay? And over here, our linked list iterator, this is an inner class. Okay, and it implements the iterator interface. And because of that, you need to implement the next method, and the remove method, okay? And so this is a constructor, okay? So we just set the next node to the first node. So that's the forwarding iterator. And then you can see we also have the list iterator method. Is it? And what iterator is the return list iterator. So list iterator in Java collection, it is a two-way. It's a two-way iterator. Okay, so it supports both forwarding and backwarding. Okay, so and the same thing for this is just specify the specified locations iterator. Okay, and because of this, we define another inner class. We call it by linked list iterator. It implements that list iterator from the Java collection library. And for this by linked list iterator, so we have the current and the last accessed, as previously we already explained, is it? And then So not just the has next. So this time has next using the count to check, is it? And has previous, then we use the index to do the check. And we also have previous index that return the index. And next index, so we also have the next method implemented. So for the next method, you also need to take care of the last accessed, okay, to update it. Because for the next, you update the current, so you also update. This is a pair. And similar for the previous, is it? So previous, then you need to update the current. Okay, that when you update the last accessed. Okay, so just be careful about this. So you have a pair you needed to update to keep track of. And similar for the remove. Okay, so here's the implementation. And then let's take a look of our testing driver. Okay, so for the testing driver, what we did is we create a new doubly linked list of the cars. Okay, and we first just add the first car. Okay, and then we add the remaining car with the specified location, and then we can check. Okay, if they all are added. And then we can test some other method like contains method, like a remove method, okay? And after we do the remove, call the remove method, then you can check if it that car did get removed from the list, okay? And you can also check the first car if the information did get updated, okay? And you can also find a car to see where the index is. Then over here, we just check for each loop, okay, to see if the iterable interface is implemented correctly. And over here, we check the two-way iterator. Okay, we start at the first and then using next do forwarding. So with the two-way iterator, we do forwarding check. Forwarding check. And then what we did is we use the list iterator, so that's a two-way iterator, is that we specify, okay, you start at the fifth location, we try to get to the iterator, is that because now this iterator located at the pretty far back of the list. So when we do traversing, we want it traversing backward. So we use the has next and or has previous and previous. Okay, we move in reverse direction to see if it works. And what next we check is still for the two-way iterator. We start at the beginning again, and then we do the forwarding as if, but this time we want to see if we find some item we are going to remove. And we are going to see the remove operation, okay, it won't terminate the loop. That's a nice thing for the iterator. Okay, so it does support the loop's continuation. Okay, with the implementation of the add and remove for the iterator interface or list iterator interface. Because otherwise, if you don't implement, don't support the add or remove for the iterator, list iterator, then you cannot do this within the loop. Okay, then the only way to do it is do the traversing one by one, do the remove. Okay. And once you remove, you got to stop. That's inconvenient because when we use linked list, if you recall the benefit, so the advantage of linked list is it support numerous adding and removing, add or remove operation numerous times, is it? So so with the support of the iterator and list iterator, the when we are two-way iterator, we can see the benefits, okay, why we can do this. And over here, we also say, okay, so here we have the illustrator, so the two-way at the front, at the beginning, is it? And then we use the hasNet and next. And this time we do the add. And you can also see after you add, the loop will continue. Okay, so this block of code, similar idea as the previous I explained. So it does demonstrate the benefits of linked list, supporting the numerous addition, adding, and removing operation. Okay, it's very convenient in this case.
目标啊，怎么样？
And so we finish the discussion of the listable interface, the linked list class definition for the doubly linked list and the testing driver for our newly implemented linked list. And here is a running result, okay? And from the running result, you can see it, yeah. So this is a single node linked list. It does add, and then we add 5 more cars, so they are added. Is it? So after we remove, if you compare these two, yeah. So car 2 did get removed from the list. And what next is we use for each loop, is it to loop from the front to the back. So you can see the result are the same. And what next is we check the loop using iterator. Okay, so similar result. And then we do the reverse way. Yeah, so you see if you compare these two, it's reversed. So the backward does working. Okay, and then we call the remove method. And then iterators remove. Okay, so it does remove that is car 5. Okay, if you See, and the loop is not terminated. So the program doesn't crash, okay? And similar for the iterators add method, we does add so after we call the add, the item did got added, okay? And the loop also continue. Okay, so that's the doubly linked list. So we complete the discussion of this section, and we will continue our discussion about linked list in the next section. Thank you.